Derivatives of logs and exponentials. We've learned the derivative of e to the x with respect to x is equal to itself, e to the x. So today we're going to talk about how to find the derivative of natural log. Let's assume natural log of x equals y, and we want to take the derivative with respect to x of both sides. We're going to use implicit differentiation because we don't know what the derivative of ln is just yet. So we're going to solve for x. To solve for x, we have to e both sides. So we'll say e to the y. Take the derivative now with respect to x. The left side becomes 1. The right side is going to be the derivative of e to the y is itself times the derivative of y, which is either you can call it y prime or you can call it dy dx, whichever, they're both equivalent. So I'll just write y prime. Great, we want to now solve for y prime. So y prime is equal to 1 over e to the y. But what is y? We already know y is y is ln of x. So this really becomes e to the ln of x equals y prime. But e to the ln of x simplifies to 1 over x. So now we just showed that the derivative of ln of x is equal to 1 over x. This is something to remember. Now it's very important that we realize ln of x, its derivative is 1 over x, but likewise the derivative with respect to, let's say, b of ln of b is 1 over b. So don't assume as soon as you see a derivative of ln, it's 1 over x. It's 1 over whatever the inside part is. Okay? To apply this to a chain rule problem, let's say we have ln of x squared plus 5x minus 6, and we wish to take the derivative of this. Well, the derivative of ln is 1 over the inside. So first step is going to be 1 over the inside times, by the chain rule, since this is two functions, ln and the polynomial, we just dealt with ln. ln's derivative is 1 over the stuff being the inside, times the derivative of the stuff, which is 2x plus 5 in parentheses. This can be simplified by putting the 2x plus 5 in the numerator, and now we have a much cleaner expression. And this is the derivative of ln of x squared plus 5x minus 6. Okay? Now what if we didn't have ln, meaning it's not base e and it's base anything else? So let's say log base 7 of x equals y, and we wish to take the derivative of the whole thing. Well, again, we solve for x, so we want the derivative of, solving this for x means x equals, to undo log base 7, we raise to the 7, so 7 raised to the y. Now we take the derivative, implicit differentiation, the derivative of x is 1. The derivative of any exponential is itself, times, and that's what we're going to talk about in this section here, the ln of this base, times by the chain rule y prime. And now we need to solve for this. So, dividing 1 over 7 to the y times ln of 7 equals y prime, but y is log base 7 of x. So really we get 7 raised to the log base 7 of x times ln of 7 equals y prime. 7 and the log base 7 cancel, and we really get 1 over x ln 7. So that tells us that the derivative now of this particular example of log base 7 of x really is 1 over x, just like a regular log, it's 1 over the inside, but you must also multiply the denominator by ln of the base. So in general, what we see is the derivative of any logarithm of any base is going to be 1 over whatever that inside is, the x, and in the denominator we multiply it by the natural log of that base. Okay, how is this used? Well, if we want to take the derivative, same example, log base 7, we're going to get log base pi, let's say, of x squared plus 10x minus 6. Then the derivative of this is going to be 1 over the stuff on the bottom, or the stuff on the inside of the log, x squared plus 10x minus 6. We're also going to multiply by the natural log of that base, and then multiply, chain rule. We got rid of the log, now we're going to address the polynomial, 2x plus 10 in parentheses, which can be rewritten as 2x plus 10 in the numerator over x squared plus 10x minus 6 times ln of pi in the denominator. And that is our derivative. As I mentioned briefly, the derivative of an exponential, so if we have, let's say, a polynomial x to the 10th, the derivative we've seen numerous times is 10x to the 9th. Reduce the exponent by 1. But what if it's the other way around? What if we have a number raised to an x? The derivative of that, of any exponential, is always itself times ln of the base. As far as using this in a chain rule, let's say we have 5 raised to the sine of x squared plus 5. The derivative of this is going to be the exponential. Anytime you take a derivative of an exponential, 5 to the x, anything to anything, is always going to be itself, no matter what that is, times ln of this base. That's the first part. Now that the 5 is dealt with, the 5 to the part is dealt with, then we say, well, what's the derivative of the next function? The next function is sine. Its derivative is cosine of whatever's inside it, as is. The 5 is dealt with, the sine is dealt with. Now what is the derivative of x squared plus 5? That would be 2x. And that is our derivative. So this part is the exponential, this is the sine, and that's the polynomial inside the sine. You see 3 functions, you should see 3 sets of derivatives. That is the general rule for taking the derivative of logarithmic expressions and polynomials. No matter how complicated they look, that's really what we're looking for.